Okay, so the exponent properties, again, you can get those from the book or just Google it. Exponent properties or rules, as they're sometimes called. Logarithmic properties. Again, I don't know if logs are going to be on the final, but they're good to review, and especially if you're wanting to correct your logarithm exam, which was exam 5, you use log properties and rules quite a bit. So, and these two are really similar, so it's good to have that. Definitely the quadratic formula. Oh gosh, formula. The quadratic formula, you use it to solve ax squared plus bx plus c is equal to 0, right? This gives you x equals insert formula here. But the quadratic formula is a real big one. We had quite a bit of formulas from exam 5, but I don't know if like the distance formula is going to be on there. I doubt it. I mean, I don't know that for sure, but you know, the distance formula slash circle or equation of a circle is a good one. Again, it's good just to work through problems, and if you come across something, it's good to have that, to know kind of what that is. One of them is, I saw it on the review, is varies directly and varies inversely. Like these two are super big, right? With k being constant of variation, right? And just to refresh your memory on these, when it varies directly, when x varies directly with y, which is what would go in here, you would have y is equal to x times k. Varies indirectly is similar, except it's inversely, right? So it's y is equal to k divided by x. And so that is one of the last one of the last problems on your review that's posted is this one. What other ones would there be?
I always get confused on when to use the distance formula, the equations of the circle, and the what's the other one?
The midpoint?
Yeah, that's the midpoint.
We're looking not at a line segment, but 2 points. So then the distance formula here would be given by a distance d between these 2 points, right? So the question is, how, like, the d distance between this point and that point. And it's really similar. Oh, hold on. Let me shade this in here. Okay, let me go ahead and write it out. So it's the square root of the distance between x1 and x2. So in the formula, they use x2 minus x1. Again, it doesn't matter. If you do x1 minus x2, then do the same for y1 and y2. And you're adding that to the quantity squared of y2 minus y1. And that is the distance between these 2 points. So it's very different than the midpoint. Again, the midpoint deals with a line segment where the distance is between 2 points. And like you noted last time, the equation of a circle is super similar to the formula.
Yeah.
So let's look at equation of a circle. Now again, it's a this final is kind of an overview of what you're going to see in college algebra. So it might not cover everything that was on exam 5, right? So, but I mean, it's good to know the equation of a circle. And the equation of a circle is, again, be thinking that you've got this circle here, and let me change the center to make it look more centered, right? So here's a circle. Let's call the center HK. Right, so the reason it's so similar to this this point is, or similar to the distance formula, is if you have a point on the line, or a point on the circle, it's saying that no matter what this point is, let's call it just some point xy, that you're basically looking at the distance from the center to this here, right? So again, you're looking for the distance on the outside of the circle to the distance, the center point, right? And we know that the point in the center to the outside of the circle is called the radius, which is r. So here, you're really looking at r is equal to the square root. And again, it's the same thing up here, except now it's written a little bit different, that you're looking at the distance between x and h, or h and x, plus the distance between y and k. Again, k being your y value of your center, that squared. And then if you square root both sides, you have your typical, or your equation of a circle that's given in the book. And it's just saying that no matter whatever xy point on the circle, it's going to be the same distance. It's going to be the distance of whatever the radius is. And that's why these two look so similar. Because, I mean, they're answering the same thing, except you're using your center, which is a really important point of a circle, which is HK. So I guess probably that's your center. Again, you can still correct exam 5. So if you're not pleased with exam 5, this is going out to everyone. You're welcome to, you can still do that if you'd like to get half points back. Yeah, so the absolute value equation. So it's saying if you had the absolute value of a equal to x, then to solve that, a is equal to x and negative a is equal to x. Right, so there's an important one. Again, remember that the number inside here can be positive or negative, and it will still give you the same. So let's look at an example. Let's look at the absolute value of 3x plus 2 is equal to 1, right? How would you solve this? I'm kind of surprised this isn't on the review, because it's a pretty good thing to know. Okay, so to solve this, we're going to use this is called the absolute value property. I don't know, or rule. If you type it in, you'll find it. Okay, so to evaluate this, it's saying that you're going to have two equations, right? The first one is going to be basically with a positive here, so 3x. Oh, hold on. It's confusing if I write it on that side. Negative x. That you're going to have 3x plus 2 is equal to 1. And then your second equation is going to be 3x plus 2 equal to negative 1. And you're going to solve each one of these for x, and plug and then make sure that they work. But that is the step to solving these type of problems here. So anytime you see an absolute value problem, you're going to have two different equations to deal with. So in this example here, you could solve subtract 2, subtract 2. So what, 3x is equal to negative 1, x is equal to negative 1/3. I didn't really pick too good of numbers. We got some fractions. So here you could subtract 2 on both sides. So that gives us 3x equal to negative 3, so 1 minus 2, or negative 1 minus 2 is negative 3. So in this case, x is equal to negative 1. Right, so you could plug these in, but you're going to see that it's going to equal to 1. So this right here would be your two solutions. So again, the big thing here is your absolute value property. I guess, I mean, you could write it just as 3x plus 1 is equal to 1, and then you could also write it as the opposite of 3x plus 2, right? Because notice up top I had the negative on the a instead of the x, but it would just be saying the same thing. You'd have a negative on the outside of this expression, and then you distribute it in, and you get the same result. So anyway, not to overly complicate that, but that's another good property, is just the absolute value property. Gonna pause the recording here. Again, like the
Oh,
answer.
because that 5 doesn't have a square root too, so
right.
you
So
can't take away. Okay.
yep, good. Yeah, that you have to have a matching. They're called the common terms, right? To combine. So, right. Oops. What you're referring to here is if you had like 3 square root 2 plus, I don't know, 3 square. Oh, that's boring. Let's do like 7 square root 2, right? That would be 10 square root 2, right? That these common terms mean that you can add them. Well, one thing I would make sure you know how to do is simplify. Just a regular square root problem. So I would say one of the more difficult problems would be something like, well, hold on, is there one on here? Let me ask, or let me look before I just say that there isn't one. I don't see one on here. I would use the quadratic formula on these. Right.
There's one, it's similar to number 9, but it's divide instead.
Okay, well, let me go back up here.
So,
Oh, that one, right?
No, the one right next to where you have it says exponent rules.
Oh, this one
Yeah,
right here.
there's that one. Yeah.
So this one, you'd probably either do synthetic division or long division. Would be how you'd evaluate this one.
What number is that one?
I'm not sure. It's the first one on the second page. Oh, okay. Yeah, that's a pretty important one too. These were the two that I was referring to. Okay, yeah, we can look at this one. So this is the first problem on the second page, and you could use either long division or synthetic division. Personally, I always go long division. I'm not a big fan of synthetic division. I've got some teacher friends who like synthetic over long division. So if one of them's watching this video when it's uploaded to YouTube, they can know that they're just wrong and they like the wrong one. Okay, so let's look at long division. How do we do this in long division? So I'm gonna use a different color. Okay, so we set it up just like regular long division. If we were dividing, let's say, 5 into 19, right? If we were going to do this, it's similar. It's not the exact same, right? Here you would multiply 3 because it'd give you 15. This would give you 4, and then now you're in the decimals. So it's not going to be a nice clean whole division in there, right? So drop the 0 down. This is now 8, so 3.8 because this is 8 times 5 is 40. Right? It's not the same, but as some of the people say, the flavor is the same, right? It's similar to that. Okay, so let's write it like x plus 3. And we're dividing this into 3x squared plus 6x minus 8. Right, so we want to divide this binomial, this 2-term, into this 3-term here, 3-term trinomial. I'm going to switch colors real quick, and we'll see why here in a second. Okay, so basically our goal here, again, it's different than regular number long division, but what you would want to do here is match this first term, right? So you want to match you want to match this. Your goal is to get 3x squared, because basically whenever we subtract, just like we did here, getting ahead of myself with all these colors, right? Just like how we subtracted 19 from 15, we would want to subtract these two, right? So you basically want to somehow get 3x squared. So be thinking, like, what number do I have to multiply to x plus 3? right? Because I need a 3x squared is what I need. So the question being, what do I multiply to x plus 3 so that I end up with 3x squared? Right, I might have, I'm going to have another term out here, but I just want 3x squared. So hopefully by this time you're screaming at your computer that it would be 3x, right? That is what you'd multiply to x plus 3, that quantity. So let's go violet, and we'll go 3x, right? And so 3x squared is going to give you 3x squared plus 9x, right? So now we've matched the term, which means, what am I going to do here? Let's take this out. The number that's going to go here, or the expression that's going to go here is 3. Oh, hold on. Pardon me. Is 3x squared plus 9x. And that is because our first term here that we're dividing into is 3x, right? Because 3x times this x plus 3 is going to give us this term, right? So now we can subtract it. Right? Our goal is to subtract this and kind of move down, right? We don't want to be dealing with this x squared. All right, so this gives us, this would be 0, and then 6 minus 9x is negative 3x minus 8. Right.
Yeah, I got disconnected. My thing died.
Very good. So we're still kind of going a little slow here on the long division, but yeah. So here's where we're at. Any questions or anything from anyone else here? Okay, so we've done that. We have to go one more time, right? Because we want to be able to again match this term here with 3x. So if I had how do I want to write this? Let's right, the goal being, I don't know, we'll choose around here. Right, I want a negative 3x here is what I want. Let me rewrite this, right? The question being, you know, what can I multiply to x plus 3, right? To get a negative 3x. Right, again, we're gonna have some other terms, but be thinking of what I have to multiply, because what goes there is what goes up here and what finishes the problem. So the number that would have to multiply to 3x to give me a negative 3x would be a negative 3. Here we can use this lighter green color. Right, so this is negative 3, and it's going to match, let me write it up here. Right, it goes up there, and then what we're going to have at the end of that is, when we multiply these together, right, is negative 3 times 3x plus 6 is going to be negative 3x minus 9, right? That is what we get here. Just multiplying those, and now you're going to subtract them. Again, similar to regular long division. Again, I'm going real slow, but if you work through these type of problems, you know, you can type in polynomial long division. That is the name of these types of problems. So if you want more practice. Okay, so let's finish the problem. So subtracting these, you get 0, negative 3x minus negative 3x. Here we got negative 8 minus a negative 9, right? So negative 8 minus a negative 9, that's going to be 1, a positive 1. Okay, so that is your remainder is 1. So to write out this answer, it would be 3x minus 3. So again, your dividend up here, plus your remainder of 1 divided by, divided by what you're dividing by. So x plus 3 here. And this right here is your solution. So it is your dividend which, or no, excuse me, it is your quotient, which is 3x minus 3, plus your remainder over your divisor, what you're divising, or, yeah.
What is that, negative 8 plus 15?
Negative 8
It's
plus
in between.
15.
It's under the negative 3 multiplied to x plus 3 in black.
Oh, right here.
In the middle.
Oh, here. Oh, this right here.
Yeah.
I was evaluating negative 8 minus negative 9.
Oh, okay.
So it's basically, yeah, evaluating. You want to look at what is negative 3x minus 8 minus negative 3x minus 9. And again, we always want 0 for this first term. So you got to be kind of thinking ahead when you do these problems, because you basically want to break down this dividend. I think that's what it's called. Well, what's underneath, right? What you're dividing into. You want to make that smaller. So by matching the first terms each time, you're able to slowly get it broken down until you're down to just a remainder. And that is how you get that there. Resume the recording. Okay, so again, synthetic division, we're going to drop this 3 down here. So we get 3, and then we multiply 3 times negative 3. That's going to give you a negative 9. Again, that's by 3 times negative 3. All right, so multiply those two together. Add 6 and negative 3. It's going to give you, 6 and negative 9. It's going to give you a negative 3. So now multiply negative 3 times negative 3. It's going to give you a positive 9. So negative 8 plus 9 is positive 1. Okay, and now we're out of terms. And anytime that you do synthetic or polynomial long division, you're going down a degree. So remember that the 2 is your highest degree, right? That's the order of your polynomial. So that means our answer is going to be in degree 1, which is why our solution, right, because we're dividing or making it smaller, is going to be 3x minus 3, and we're going to have a remainder of 1. And we find that it is the same thing we found using long division. So I really like long division. Synthetic division, you just need to know that this first term here needs to be an x, right? X to the first power can't be anything different. And that basically the number that goes in here, your c, it might actually be r. I think when we taught it, we looked at it in class, I think this was minus r. I think. It doesn't matter. I'm going to keep a c if I can get it back. So you're right, this is what c is. So c in this case is negative 3. Right, and then you set it up by descending order, similar to long division, and then have those. So that is how you do those types of problems. There's 2 options. It's either synthetic division or polynomial long division.
So how would, so because right, you're supposed to rewrite it with the lower degrees, right?
Mm-hmm.
Is that what it says 3x minus 3 is?
Yeah, so you could think we started with 3x squared plus 6x minus 8, right? So we started with this degree of 2. That means whenever we do our division, well, let me go down a little bit. That means whenever we would do our division, let's say we had like 3x cubed plus 2x minus 1, right? And we're dividing it by just an x minus 1, like this. That whenever we do our long division, it's no longer going to be x cubed because we're dividing in x to the first. So we're dividing in x to the first. That means we're going down 1 degree, and we're going to wind up with some coefficient. We don't know what it is. Our job's to find that. x squared plus some other coefficient, x, plus some constant, right? Just some number, and then possibly a remainder, right? But we don't know. So we could set this up to be synthetic. Do you want to do this other one as synthetic division or polynomial long division? What would you prefer?
The first one we did was polynomial long division, right? And
Right.
do synthetic because
Okay.
I'm still
So
confused.
yeah, okay. So we'll put it. We'll do this in synthetic. So again, let me switch colors here. You need this stupid thing. I'm gonna change colors. I don't know why it does what it does. Right. So you need a minus sign, right? So to set up synthetic division, you need x minus c for some number here, right? So that means when you set up synthetic division, your number that's going to go here is c, right? It's going to be the opposite of whatever's in the inside of your divisor, right? The constant term inside. So in this case, when we set up this term here, it's going to be -1, right? So that there is like the first step, is what number goes in here. It would, oh, excuse me, it'd be 1, right? It's the opposite of whatever's in the inside. So it's your root is what you're dividing by. So just terms. All right, so you get 1 there. So another thing is to notice that we don't have an x squared term, right? Notice that 3x squared, or excuse me, 3x cubed plus, and we have 0 times x squared plus 2x minus 1, right? Notice we've got a missing term here, right? Our missing term is x squared, which means the coefficient is 0, right? It's not there. Okay, so the reason that we write it like that is it's going to help us whenever we set up our synthetic division. Okay, so we've got 1, right? 1 was the opposite of what's in the inside of the constant term here with our divisor. So then our coefficients are going to be 3. Oh, man, excuse me.
Because that under the x minus 1, it would be x minus -1 again, or
So right here would be, okay, hold on. So let me set it up here. Gosh, this thing's messing up on me real quick. I think it's this one, right? All right, yeah, so we're gonna set up here. So it would be 3, 0, 2, and -1. It's the numbers in front of the coefficients, right? And you do it in descending order, which means that you would do 3 because it's in front of here. Then you would do a 0 because that's our x squared term. That's why there's a 0 there. And then we would have 2, it's a coefficient in front of the x to the first power term here. And then we'd have our constant of -1. And this is what we're going to do synthetic division on. Using
so 0 plays as the x squared.
Right,
That's
right.
not there.
So we'd have to include that. So that's an important thing with synthetic division is if you're missing a term, you got to plug it back in there. So we have it. So let's go ahead and do our synthetic division. So our 3 drops down. We're multiplying it to 1. Again, it's the opposite of whatever's inside here, right? X minus our constant term, opposite of that. Okay, so we get +1. So 3 times +1 is 3. Add these together, we get 0. 0 times 1 will be 0. And then we're adding down still. Let me go over here. 2 and 0 is 2. 2 times 1 is 2. Okay, so here we are. We've done that. Now last is -1 plus 2. This is our remainder term if there is one. And looks like there is because we get 1. This is 2. So this right here is your remainder. Okay, but notice we're dividing again x to the first power into this 3x cubed, which means this right here, help me out, it's going to be x to the what power? If we're going down a power.
It's going to be 3x squared.
Perfect, 3x squared. This is your x to the first power, so you get 0 times x to the first, which is just 0, and then you get 2, plus your remainder term. remainder
That's
of 1.
0. Why is it still 0 if it's like
Um,
that's 3 and there's a 0 and there's a 3 under it?
so, oh my gosh, good catch. I don't know. I don't know why that was there. Yeah, no, that's 3. Yeah, thank you. Yeah, I went too fast. Oh gosh, well that messes everything up. All right, one sec. I couldn't do multiplication correct. Okay, good catch. So 3, that's 1, 3, that's 3. 3 times 1 is 3. Here we are, right? So, okay. So 2 and 3 is 5. 5 times 1 is 5. So again, adding this together, you get 4. Okay, so our remainder is 4. I added incorrectly or multiplied wrong. Go through this real quick. 5. Okay, good. Okay, so actually here we have all of our terms, right? So that means our quotient, I'm going to scoot down just a little bit, is going to be 3x squared plus 3x plus 5 plus our remainder term, which is 4 divided by our divisor, right? So this is equal to this polynomial long division problem, right? Where we divide, or actually here, let's write it like this. 3x cubed plus 2x minus 1 divided by x minus 1. Now, yeah. Right. Just another way to rewrite the problem is like that. And that would be our long division. Now again, we could do it with polynomial long division, but it would be similar.
So when you put it, you see how you rewrite it at the end?
Yeah.
You don't put the 4 down, the remainder?
The remainder is here, 4 over the divisor of x minus 1. But this right here is one way to write the solution like that.
Okay.
I think on the answer key he has it written as this, and then your remainder term of 4. So that there's another way to write it.
Okay.
So yeah, again, synthetic and polynomial long division they do the same thing. It's just the synthetic, there's a couple things you need to make sure of, like you got to make sure to pick the right number to do your synthetic division by. Again, excuse me. Again, choosing the root to be that. So.
What about it's for it's solving an equation. It's 4x plus 5y equals 5, and then 8x plus 5y equals 5 or 25.
Okay, let me see here.
It's on part 3.
Oh, here, sorry. I paused it again. All right. Solving a system of linear equations.
So I got to multiply one of them by a negative?
Yeah. So I would use the elimination method, which is what you're describing here. So yeah, so you can multiply one of these by a negative number, right? Because you want your coefficients to be the same but opposite, right? So when you add straight down, one of them goes to 0. So what should we multiply here?
Negative 2.
Okay, so which one would I multiply by a negative 2?
The 4x plus 5y.
Yeah. So that right there will give us a negative 8x, which is what we'd like to get rid of the x's. So this gives us negative 8x minus 10y equal to negative 10. Go ahead and rewrite the other one that we didn't do anything with. So we got 8x plus 5y is equal to 25. All right, so here we can add these together now, right? We've got our matching terms here, the same but opposite, right? One positive, one negative. So adding these together, we get 0x. Sorry, I saw someone was in the chat, but I can't see the chat. Oh, okay. Have a good night. All right, let me continue on here. Okay, so we get 0x, which is, there's none there. So negative 10y plus 5y is going to give you a negative 5y. Right, adding the y straight down. It's kind of hard to see, that's a y. Right, so negative 5y, negative 10 plus 25 is going to be 15. So dividing by negative 5 on both sides, we get negative 3 is equal to y.
Then you plug it in, right?
Perfect, yeah, and you can choose either one to plug it into. I'm going to choose to plug it into the top one, 4x plus 5y is equal to 5. The numbers are a little bit smaller there, so it's a little more enticing to plug it into that. So y is equal to negative 3, and we're going to sub in to 4x plus 5y is equal to 5. All right, so we got 4x plus 5 times negative 3. That's equal to 5. So we get 4x minus 15 equal to 5. So add 15 on both sides. We've got 20. Divide by 4. We got 5. So our solution here is y is equal to negative 3 or x is equal to 5. Or you could report it as an ordered pair, because again, this is describing two lines that are intersecting. So the point 5, negative 3 is where these two lines intersect. So we probably have time for one more question to work through here. I'll erase that. Again, that's just using the definition of varies directly is how you would do that. And then here you need to find what k is equal to. So you're going to use, that doesn't work as well. You're going to use that equation that you set up to solve for both x and y. So again, I would say refer back to the key, but really what you're using is the definition of varies directly. Which again is a pretty good two formulas to know, would be varies directly and varies inversely. Looking at the graphs here. So anytime that you're graphing something, is that the only two? It's good to have some points picked out that you're going to plug in. Now, for this here, graph the equation, this is going to be a parabola because you've got a squared term. So anytime you've got like x squared, its graph is gonna look like a parabola. Right, so that's the shape of that. When you've got, excuse me, let's do y equals, right? If you've got again, you could have other terms here too, but x squared is your degree, your highest power, which means that your graph's going to look like a parabola. If you just have x, right, like y is equal to mx plus b, right, you're going to have a line. So it's right like this. So these are two important ones to know. Now, I'm writing this here, x squared plus k. This parabola is given in vertex form. So you'll use the vertex to find that. Let me see if the answer key, if he has it written, if he's done. Yeah, so in vertex form, y is equal to a minus h squared plus k. That's probably a good formula to know, is the vertex formula. So this is called vertex form when it comes to graphing. That and slope intercept form is another good one to know, because you'll use that up top, slope intercept form. So it's a good review of how to graph a linear function. But if we wanted to graph this parabola, your vertex is your point, is either your minimum or your maximum, which is HK. So vertex form is important because it gives you the vertex, and the vertex is either the lowest or the highest point of the graph, right? You'll either have a hill or a valley, kind of like how we have up here. All right, so in this problem here, this 2 and this 4 is our vertex. Now again, in the vertex form, it's minus h, so it's the opposite of whatever you see. Anytime you see a negative in a formula, it's a little confusing, but it's the opposite of what it is here. So your vertex in this problem is -2, 4. And so basically what the vertex is going to tell us, so we go over here, where are we at? -2 up to 4. So here's your vertex. Now that means we're going to have a line of symmetry through this point, right? Because our parabola is either a hill or a valley. That means it'll either be opening up or down. Do you remember if it'll be up or down? Do you remember like what tells you if it's going to be a hill or a valley?
If it's positive or negative.
Right, yeah, and the number that determines that is this a term, this a coefficient here. So, but really, you could plug in some values and you'll see whether it opens up or down. So, I mean, the question always is like, what points should you pick? Again, looking at the x and y. So anytime you have to graph, plotting an x and y input-output graph is good. And what you want to do is you're going to start with -2. -2, 4 is going to be your center point because that's what the vertex is. It's important to be able to find the vertex because then you can basically plot an x value that's less than that, so -3, and then plot one that's greater than that, so -1. So finding whatever -3 and -1 is going to give you, whatever the outputs are, excuse me, that'll basically show you your outline of the parabola. So let's figure out what that is. So I'm going to look at x is equal to -3. So that means you're going to have, plugging it in here, x, oops, -3 plus 2 squared plus 4. All right, so evaluating this is -1 squared plus 4. It's +1. We get 3. So it looks like -3 is going to give you 3. So what's nice is because it's the vertex, it's going to be symmetric, which means this other point is going to be 3. All right, so it's symmetric about the vertex. So we get 3 for both of these, for -1 and -2. Graph's kind of hard to read. There it is. All right, again, I like to find more points, so you could be looking at 0. Right, if you plug 0 in here, you'll find that it is, just do this real quick, 2, that'd be 4, 2, 4, -4 would be 0. So your other point is at 0, 0. So the big thing here is to be able to find the vertex, and then you can get a nice symmetrical graph. Let me try to make this brighter looking. Yellow. So you get a graph that looks like that. Again, Alex will have you pick points to graph it, and so find the vertex, and do that, or find the vertex, and then find points symmetric about that vertex, and then you'll be able to graph it. The last thing I'm going to add is to the list of what I think is important. Or have you written everything down?
I've been trying to keep up. Yeah, I'm just
Sure.
graphing the point now. So.
Go ahead and finish it. I'm going to add to this here. I'll unpause the screen so you can see what I'm writing. So just finish writing that down. And then I'm going to write down some other important things I would say to know. Yeah, so I mean, graphing these, the methods vary a little bit, but really it's just being able to know what point to plot, and then going from there. So again, that's how you do like one in a vertex form.
I got that one written down now. The graph.
Okay. All right, so we're probably gonna end here, but these are some other important things that you'll use on that graph there for sure. Excuse me, on the final exam review. Slope intercept form, again, m is slope, and that's given by the changes of the y's, so y2 minus y1 divided by x2 minus x1. Again, you won't use this per se on the problem on the final exam review, but it's still important. So again, slope is telling you rise over run, right? So it tells you how far you're going to go up or down, or left or right, right? So B is the y-intercept. So I would say those are good to have for the graphing, but I mean, we've covered so much, it's kind of tough to see what will be on it, but just work through that final mock there.
Okay.